Okay, so let's begin with our new chapter of electric current. Okay, so for the first subtopics, we're going to talk about the conduction of electricity. So the conduction of electricity is actually usually occurs in the metal. So as a general knowledge, we all know that the metal is actually a good heat conductor. So this is because metal consists of free moving electrons. So free moving electrons will decide the metals as a not heat conductor. Free moving electrons will actually decide the metal as a good electric conductor. So free moving electrons. Okay, so this is because I'm sorry, free moving electrons free moving electrons can move with high speeds with high speeds um, and random motion. So before connecting to the power supply, the free moving electrons can actually move with the high speeds and random motion. So the free moving electrons can be said that the free moving electron is actually detached from each respective atoms, and hence that is the reason why the free moving electrons can carry the electrical charges from one point to another point. Alright, so if we are going to determine how much electron is inside in a specific metal, so my specific metal is actually meant different type of metals such as copper, silver, and other metals. So if we are going to determine how much electron are inside in a specific metal, and hence what the terms that we use is actually um okay, so let me just okay, so the terms what we use is actually the number of free moving electrons per unit volume. So we actually determine the number of electrons in the terms of number of free moving electrons per unit volume. So the number of free moving electrons is also called as the free electron density. Sorry. Okay. So we also call this one as the free electron density. Free electrons density of a metal. So the symbol we actually denote it as small letter n. Okay, so different types of metal wire has different free electrons density. Alright, so this is the introduction for the metal and the free electron density. So we're going to discuss about the derivation for the free electron density. Okay, so the derivation of free electron density. So from these words, this density, so we know that the basic formula is actually came from the formula of density. So the density is actually equals to the mass divided by volume. Okay, so we know that the mass is actually equals to the multiplication of moles times the molar mass. So the molar mass is the mR, capital letter M, and R. This one is actually the symbol for the molar mass. So this is the N. So if I wish to derive it in terms of number of moles per unit volume, so this mole has the same symbol as the free electron density, which is the small letter n. So I use this blue color to represent the moles. So this blue color small letter n is actually the represents moles. So the moles divided by the V is actually equals to the molar mass divided by the sorry, not my mistakes. So the number of moles per unit volume is actually equals to the density divided by the molar mass. Okay, so if I wish to find out the number of atoms, okay, the number of atoms per unit volume of the metal, number of atoms per unit volume, okay, per unit volume of a metal. So the number of atoms per unit volume of a metal is actually well known as the free electron density. Free electron density of a metal. Alright, so if I wish to find out the free electron density of a metal, means the whole how should I say that? The whole the total atoms which included inside the metals. So what I can do is actually multiply the both sides by the Avogadro constant. So finally, I can conclude that my free electron density of a metal is actually equals to the density multiplied by the Avogadro constant divided by the molar mass. So this is the free electron density. Alright, so we have done for the introduction. So let's move on to our main subtopics, which is the electric current. Alright, so electric current. So what is actually the electric current? So electric current is actually defined as the rate flow of charge. So the higher the rate flow of charge, the larger the quantity of the electric current. Okay, so the formula given is actually I is actually equals to the dq over dt. So if I wish to find out the relation between the electrical charges, which is Q, and I, which is electric current, so what I need to do is actually move this dt to the both side, to the other side, sorry, and this is dq. So what I need to do is actually integrate the both sides. So From here, what I can get is actually Q. So this, if I wish to integrate, so what I can get is actually IT. So the constant is actually can be ignored, okay, can be neglected. So what I get is actually the formula of Q is actually equals to IT. So this is the relation. So since the charges are carried by the electrons, so as I said from the at the beginning, so since the charges are carried by the electrons, so the electron is actually means the free moving electrons inside the metal. So hence the electric current is actually caused by the flow of free electrons. So the free electrons, okay, so the free electrons and the electrical charges will actually produce the electric current. So what is the way that free electrons and the electrical charges, so this is S, so how can they actually produce the electric current? Okay, so we will discuss later. So before that, we need to know another formula, which is the total number of free electrons flow in t seconds. Okay, so before that, we need to know the formula of the total number of free electrons flow in t seconds. So we know that Q is actually equals to IT. Okay, let me just observe for a while. So for another formula, which is the electrical charges. So since the electrical charges is produced by the free moving electrons, and hence the total electrical charges which produced inside the metal is actually the total of free moving electrons inside the metals, which is Q is equals to NE. So this capital letter N is actually meant by the total number of free electrons inside the metals, inside the metal wire. Sorry. So if I wish to equating the both equation, so what I can get is actually IT is actually equals to NE. So the total number of free electrons flow in t seconds, which is N over T, is actually equals to I over E. So this is another formula. Okay. So this is actually in the condition when the metal wire is carrying the electric current. So what happened to the free moving electrons if the power supply is not connected to the metal wire? Okay, so when the conductor is not carrying a current which is not connected to the power supply, so metal wire, okay, let me just zoom it a bit. So when the metal wire is not carrying a current, okay, so if the metal wire is in the condition where when there is no current flowing from one end to the another end, So it means that there is actually no electric field supplied. So no electric field is supplied. So if the metal wire is not carrying a current, it means that the wire is actually not supplied to the electric field. So my free moving electrons are actually moving in random motion, random and high speeds, random motion, random motion with high speeds. So if the free moving electrons are moving in random motion with high speeds, it means that, okay, so it means that there is actually no so if the, okay, I repeat again, if the free moving electrons is moving with the random motion with high speeds, it means that the net velocity, so the net velocity is actually equals to 0. So the net velocity is actually is equal to 0. It means that no net flow of charge. So the no without the net flow of charge, and hence I can conclude that no electric current is produced. So this is the condition when the metal wire is not connected to the power supply. So we discuss again. So for the first condition, if the wire is not carrying a current, no electric field is supplied, and free moving electrons are actually moving in the random motion with high speeds. So for the third reason, the high speed of free moving electrons causes no net velocity occur between the free moving electrons from one point to another point. So if the net velocity is 0, and hence no net flow of charge, and thus no electric current is produced. So this is the discussion about the metal wire which not carrying a current. Alright, so let's just now we discussed about the electric current, and the free moving electrons will actually produce the sorry, I repeat again. So we discussed about the free electrons and the electrical charges will produce the electric current. So what is the way that they produce the current? And hence we are going to talk about the mechanism of the conduction of electricity in metal. Okay, so mechanism of conduction of electricity in metals. Okay, so for the first statements, if okay, so this is actually the condition when the metals is connected to the power supply. Okay, so before that, let me just draw something to as a reference. So this is actually the wire. Alright, so this is the wire, and this is actually the potential difference, and this is actually the potential difference that supply to the wire, and this is the length of the wire, which is from this point to another point. So I regard this point as A and this will be B, and this is the L, and the electric field is actually flows from A to B, and sorry, this one should not be here, and the potential difference across the exists across the A and B. Alright, so for the first statements, when potential difference so as a note that I suggest if you are going to answering the mechanism of conduction of electricity in metals for a questions, I suggest that you should write in terms of paragraph instead of the number instead of point by point, which is 1 2 3 4 5. So this is actually for my as the reference for you. Okay, so let's begin. So when the potential difference is supplied across A and B, hence the electric field, so the electric field is actually the key for the first points. The electric field is produced within A and B. Alright, so when the potential difference is supplied across A and B, hence the electric field is produced within A and B. Okay, so from the previous chapter, such as capacitor and electrostatics, so from the both chapter we actually learn the formula for the electric field. So the electric field, okay, let me just use another color. So the electric field, so this is the direction of the electric field which flows from A to B. So the electric field is equal to the potential difference across the two so this case is actually not the plate, not the capacitor. So this case is actually the wire from A to B. Okay, so I denote this one as VAB, okay, divided by the separation of 2 points. So in this case, the separation of 2 points is actually the length of the wire. So this is LAB. Alright, so this is the first statement. Okay, so electric field. For the second statement, so the electric field produced causes the free moving electrons okay, so the free moving electrons to be, so this is our key, accelerated due to the electric force. So this electric force is also well known as the electrostatic force. So the electrostatic force or the electric force can cause the free moving electrons to be accelerated. Okay, so the electrostatic force is actually acts on every electrons which contain inside the metal wire. Alright, so from the formula, from the chapter of electrostatics, so we did learn the formula for the electric force, so which is F is actually equals to EE. So for the most basic formula, fundamental formula for the force is actually MA. So from here I can derive the formula for acceleration. So the acceleration is actually equals to the electric field times the electrons divided by the mass. So this is the acceleration of the electrons. So this mass is actually the mass of the electrons. Alright, so this is the second statement. So if we repeat again, so if the electric field, when the potential difference is applied across A and B, hence the electric field is produced. So this is the electric field. So the electric field can cause the free moving electrons to be accelerated due to the electric force. Alright, so after accelerating the electrons, so the accelerated electrons, not electrons, sorry, we should write it as the free moving electrons. So accelerated free moving electrons will then collide with the lattice atoms. So consider this one is the atoms or the ion. So I can say that this one is actually the ions. This is because the atom is actually lose the electrons, since the electrons is actually free moving inside the metal wire. So this one is actually the atoms of ion, atoms or ions. So this is actually the electrons. So the electron is actually being accelerated. So the electron is being accelerated due to Fe, the electric force. Okay, so the accelerated electron due to the electric force will then collide with the atoms. So the collision between the electrons and the atoms can cause the speeds of the electrons to be decreased. So the decrease in the speeds of electrons, so I just briefly describe the process. Okay, so I'll write the description later. Okay, so this is when the speed of electron to be decreasing, and hence this actually creates the net velocity. So as we can see that the speed of the electron is decreasing due to the collision between the electrons and the atoms, or I can say that as ions. So the speeds of electron decrease, and the decrease in the speeds of electrons can create the net velocity. So this net velocity, as we said that from the previous parts, we said that the net velocity can produce the net flow of charge. So the net flow of charge will produce the electric current. So the electric current, So this is actually the whole process for the mechanism of the conduction of metal wire. So I briefly explain this. So let's get back to our description just now. Okay, let me just erase this one first. Alright, so accelerated so for the theory just now we discussed, it's not necessary for us to write it so long, and hence we just write it is as general. So accelerated free moving electrons collide with the lattice atoms. So we direct go into the net velocity. So the net velocity of the free electrons, well known as drift velocity. Okay, so this actually do not have a dash. So the free electron is also well known as the not free electron, sorry. The net velocity of the free electron is also well known as the drift velocity. So the net velocity is due to the collision of free electron with the atoms. Okay, so this is actually well known as the drift velocity. So the drift velocity has a symbol which is v, and above v we add something which is the bar. So this is the symbol for the drift velocity. Okay, so the net velocity, um, well known as the drift velocity, will finally produce the and the drift velocity will finally contribute to the net flow of charge. Okay, so this is the net flow of charge. Okay, so we discussed about the direction of the electrons inside the electric field. So from the chapter electrostatics. So if the electric field is moving from the left to the right, it means that the electrons is actually always oppose the direction of free sorry. Okay, I repeat again. So if my electric field is actually moving in the direction from A to B, so it means that the free electrons will always oppose the direction of electric field. Okay, so this is actually oppose the direction of E, So in this case, if the electric field, so in this case, if the electric field is supplied from in the direction of point A to point B, and hence it means that the direction of flow of a free electron is actually moved from B to A. Okay, so I can conclude that my description for the number 4 is actually the drift velocity of free electrons is opposite direction to the electric field. Opposite to the opposite direction to the electric field. Let me just electric field. Okay, so the drift velocity of the free electron is opposite direction to the electric field. So as we talk about the net flow of charge due to the net velocity of the free electrons. So hence the net flow of charge will actually will produce the electric current. So the electric current is actually opposite direction to the, okay, so this is just as a note. So electric current is always opposite direction to the electric field. Not electric field, opposite direction to the flow of free electrons. So the electric current is actually opposite direction to the flow of free electrons. Okay, so it means that the electric current is actually in the direction of the electric field. Okay, so the electric current is actually in the direction of electric field, which is also opposite direction to the flow of free electrons. Alright, so I think that's it for this today lessons. So we will discuss this chapter in the next video. So I'll see you next time. Thank you. Bye.